Okay, this is our Chapter 2 Measurements and Calculations Review Problems. So the first problem says, give the 4 conversion factors for picometers to kilometers. Now the first thing I'm going to do is make this a little bit easier, since this is an introductory exercise here, and we're going to change the kilometers to meters. That will make our conversion factors a little easier. We can do these two-step conversions once we get more comfortable with the one-step conversions. So the first thing we need to do is to give our 4 conversion factors for picometers to meters. To do this, we reference this table of SI prefixes, and we find the pico prefix, which is right down here. We have the pico prefix, and we see that it represents 10 to the negative 12th of whatever unit we are looking at. So, and also over here, 1 picometer is equal to 1 times 10 to the negative 12 meters, for example, and that happens to fit the example that we're looking at right now. So we can use this information to form our 4 conversion factors. So coming back to our problem, we will construct our 4 conversion factors for picometers to meters, and then determine which one we can use to solve the problem that is given here. So 1 picometer we can say is equal to 1 times 10 to the negative 12 meters, and that's from that table that we just looked at. And we can take the reciprocal of this, which is 1 times 10 to the negative 12 meters over 1 picometer. And then what we can do now is we can manipulate the numbers here a little bit so that we are converting with 1 meter in its relationship to picometers. So 1 meter we'd say is 10 times 10 to the 12th picometers. So instead of 1 times 10 to the negative 12 meters that we have in the first 2 conversion factors, we can change to an exponential representation of picometers. But when we do so, we change from a negative 12, 10 to the negative 12, to 10 to the 12th. So 1 meter is equivalent to 1 times 10 to the 12th picometers. And we can take the reciprocal of that. 1 times 10 to the 12th picometers is equivalent to 1 meter. Now we can look at our problem and determine which of these conversion factors will help us to solve the problem. So our problem says convert 9.36 times 10 to the 26 picometers to kilometers. And again, we're going to change kilometers to meters to make it a little bit simpler here in the beginning. Okay, so when attacking problems, conversion factor type problems, it's always good to remember the basic formula that the quantity given times our conversion factor will give us the quantity sought, the quantity that we are trying to find. So next, it is good practice in chemistry to write things in fractional form and include the units as well. That helps tremendously when we move forward into the more complicated types of problems that we have to solve in chemistry. So we will write 9.36 times 10 to the 26 picometers over 1, and that is the value that we're given right up here in the problem. Now we have to choose which conversion factor will allow us to convert from picometers to meters. So we're going to determine which conversion factor will cancel out picometers and thus result in meters. In looking for this conversion factor, we're going to want a conversion factor that has meters over picometers as the conversion factor, because that will allow us to cancel out our picometers and result in the meters. So we look at our 4 conversion factors up at the top that we determined prior to starting the problem, and we see that the 2 in the middle, 1 times 10 to the negative 12 meters over 1 picometer, or 1 meter over 1 times 10 to the 12th picometers, both give us meters in the numerator and picometers in the denominator, which is what we need to cancel out picometers. So we can choose one of these. So I'm going to choose 1 times 10 to the negative 12 meters over 1 picometer. So this will equal 9.36 times 10 to the 14th. Because our picometers cancel out, our units are meters, and that is the answer. That is the conversion of 9.36 times 10 to the 26 picometers to meters. The next problem we will look at is starts off asking you to convert kilograms to milligrams, but again, I think that at this point that may be too difficult, so we're going to change milligrams to grams, and that will become much easier. So again, we're going to reference the table of our SI prefixes to figure out our conversion factors. So the problem is asking us to convert kilograms to grams. So what we need to do on this table here, until we get familiar with some of these and start remembering them just from basic use, is we find kilo, which is our prefix, and there it is, there's K, and we see that it represents 1,000, or its factor, its value is 10 to the third, and as I've already circled over here, it represents 1,000 of the particular unit. So 1 kilometer, or 1 kilometer, it represents 1,000 meters, or is equivalent to 1,000 meters. So when we come back to our problem now, we can figure out from the table, and knowing what the kilo represents in the kilogram, we can construct our 4 conversion factors. So we can say 1 kilogram is equivalent to 1,000 grams, 1 kilogram over 1,000 grams, and the reciprocal of that, of course, is 1,000 grams over 1 kilogram. These two fractions here are equivalent to 1 and equivalent to each other. Now we can manipulate the numbers here a little bit so that we are converting, or we're showing the relationship between 1 gram and kilograms. So 1 gram would be equal to 0.001 kilograms. That's 1/1000th of a kilogram. Or we could also write this, and you see this sometimes, as 10 to the negative 3 kilograms. Okay, so right now I'm going to get that out of the way so it's not too confusing, but that is another way to represent 0.001 kilograms. And then the reciprocal of this, of course, is 0.001 kilograms for every 1 gram. All of these are equivalent to each other and equivalent to 1. So now we look at our problem. It says convert 743.1 kilograms to milligrams, and again we're going to change that to grams to simplify things here. So once again, the best thing to do is write your quantity sought, multiply that, or your quantity given, excuse me, multiply that times your conversion factor, and that will give us our quantity sought. So the quantity that we are given, we write this as a fraction. We have 743.1 kilograms over 1, write it as a fraction, and include the units. And now we have to determine which conversion factor will get rid of kilograms and give us grams, because that's what we're asked to do. So we're going to look for a conversion factor that has grams in the numerator and kilograms in the denominator. And so when we look up at the top here, we see again that our middle two conversion factors, I've already chosen one here, but our middle two conversion factors give us grams in the numerator and kilograms in the denominator. So I'm going to choose the 1 gram over 0.001 kilograms. Now, you could also write this as 1 gram over 10 to the negative 3 kilograms, because that is equal to 0.001 kilograms. Now, again, I'm not going to leave that there for confusion's sake, but that would be the equivalent conversion factor. It says exactly the same thing. Okay, so now we go ahead and cancel out our kilograms, and then we do the math, and we get, I'm not sure what I did there, but we get 743,100 grams. And I'm going to move that back over so it's a little closer to our math over here. And this is a relatively large number. We could convert this number to scientific notation, which is also probably a good practice. So we would say 7.431 times 10 to the 5th grams. Now either one of these answers right now would be considered correct. That's how we would convert 743.1 kilograms to grams. Okay, next we will look at number 3, which is what is the volume of a substance with a density of 4.396 grams per cubic centimeter and a mass of 12.108 grams. So I'm underlining the pertinent information here. And when you have a word problem like this, it's best to pull the information out of the words and write it down in a separate place. That helps us to better understand what it is that we're given, what it is that we're trying to find, and how to plug it into our formula when we get to that point. So I'm going to write density is 4.396 grams per cubic centimeter, and our mass is 12.108 grams. And that's the information that is given to us up in the problem. So now I find it helpful to write the quantity that we are sought, write that out with a question mark. So we are looking for volume, so volume is equal to what? This, I think, is a good way to start because it clues you into what your ultimately what your equation will need to look like to solve the problem. You need an equation that starts with V. Volume is equal to what? Well, we know from the density equation that it says that density is mass divided by volume. We can manipulate that for V, for volume, and when we do so, we get volume is equal to mass divided by density. Well, we are given mass and density, so now we just plug in our numbers. So volume is 12.108 grams over 4.396 grams per cubic centimeter. And over here on the right side, okay, I've done a lot of math here, but over here on the right side, I'm showing you that when you have x over y, the x's cancel out, and the y actually becomes the value that we have solved for. So x over y is equal to y, just like in this, it clues you into our units, how to solve here. G over cubic centimeters is equal to cubic centimeters. So when we plug this number into our calculator, we get this big long value. Volume is equal to 2.754322113 or 111, excuse me, cubic centimeters. Well, this number has way too many digits in it. We need to give an answer with the proper number of significant figures. And so we look at our two values. Density is 4.396. Mass is 12.108. Our first value has 4 significant figures. The second one has 5. So our answer needs to have 4 significant figures. So we'd round that to 2.754 cubic centimeters. That's our answer for the volume. The next problem says, what is the mass of a substance with a density of 1.138 grams per milliliter and a volume of 57.1 milliliters? Okay, so again, look at the information that we're given here in the problem and pull out what information that you are given and write it out to the side. So we are given density and volume. Density of 1.138 grams per milliliter and a volume of 57.1 milliliters. So again, manipulating the density equation can allow us to find for mass. So we're looking for mass. So the mass is equal to density times volume, that we can figure that out from our density equation. We're given density and volume, so this is simply now we're just plugging in our numbers here. So mass is 1.138 grams per milliliter, that's our density, times 57.1 milliliters, that's our volume. And again, it's helpful to write things in fractional form. This allows us to cancel out units properly and sets us up for success when we get into our chemistry problems later on. So our milliliters will cancel out, and we get this value for mass, 64.9798. But this is a number that has too many digits in it, too many significant figures. If we look at the data that we are given, our density is 1.138 grams per milliliter. That is 4 significant figures. And our volume is 57.1 milliliters. That is 3 significant figures. So our answer has to be equivalent to our given value with the fewest amount of significant figures. And so that would be 3 sig figs. And so we would round our answer to 65.0 grams. That is our answer for the mass of this substance. Okay, our final problem says the largest golden nugget had a mass of 100 kilograms and a volume of 5,181.35 cubic centimeters. And the question is, what was its density in grams per cubic centimeter? Well, again, for simplicity's sake, I'm going to modify this problem a little bit to help us out. So we're given a mass of 100 kilograms. I'm going to change the 100 kilograms to grams for you, which is something that you would have to do through the course of this problem. But just to focus on finding density here, I'll go ahead and tell you that that is 100,000 grams. So we are given mass and volume. We write this, and we need to find density. So we write our mass and our volume out to the side. Mass is 100,000 grams, volume 5181.35 cubic centimeters. And we are asked to find density. So we use our density equation. Density is mass divided by volume. Plug in our numbers. 100,000 grams is our mass divided by 5,181.35 cubic centimeters is our volume. And then we just do the math here. We have 19.299989939, which is way too many significant figures. If we look at the data that we're given, we see with mass we have 100,000 grams. That actually only has one significant figure there. And in our volume we have 5181.35 cubic centimeters. That right there is actually 6 significant figures, but because of the rules regarding significant figures, we have to use the value that has we have to have the equivalent number of significant figures as our value or a measurement with the fewest, which is only 1. So we have to have an answer with 1 sig fig. You might be a little confused as to how to round 19.2998939 to a number with 1 significant figure. But when we do this, we get 20. 19 rounds to 20, because 20 is an answer that has just 1 significant figure. 20 grams per cubic centimeter is the answer here.